In the second section of Chapter 10, we're going to talk about circles and regular polygons. So by the end of this lesson, you should be able to develop and apply the formulas for circles and regular polygons. So let's start with circles. A circle is a locus of the points in a plane that are a fixed distance away from a point called the center of the circle. Basically what that means is you start with a center, you grab a certain distance, and then you make every single point that fills up that distance all the way around, so that every single point on this circle is exactly the same distance away. A circle is named by the symbol this. We don't just do an O because it could look like an O, so we draw a dot inside of it, and that's its center. So circle A has a radius r and a diameter of d. So when we say circle A, that talks about the very center of our circle. Radius is the distance from the center to the outside, and then diameter goes right through the middle and connects two opposite ends. The irrational number pi is very important with circles, and it's defined as the ratio of the circumference to the diameter, or pi equals c over d. I want you guys to prove this. So I want you to find an object somewhere in your house after you get done watching this, like a soda can. And I want you to find the diameter. So in your soda can, you would take this distance right here, find your diameter. And then I want you to find the circumference. So you got to measure all the way around. You can do that with a rope or a string or something, and then put it on a ruler and find the distance. And then I want you to find the ratio. So take the two numbers that you found and do circumference divided by diameter and see what you get out. So using this relationship of pi, we can solve for the circumference of a circle. And circumference is pi times the diameter. Or because diameter is twice the radius, we can also say that circumference is 2 pi r, 2 times the radius times pi. So then we can use the circumference of a circle to find its area. If we take a circle and cut it up into like pizza slices, we can put those pizza slices together and it kind of makes this parallelogram, this red shape here. And because all the outsides here are the circumference, we have about half of the circumference on either side. And then we know that circumference is 2 pi r. So because we have about half of it, we have the base being pi times the radius. And this height here is the height of one of my pizza slices, which is the radius. So we can see that this parallelogram's area would be base times height, or pi times radius, or pi r squared. So you need to know that the area of a circle is pi r squared, and that's kind of where it comes from. So here are your formulas. Circumference, there's two of them. It's basically the same formula, and area, pi r squared. So find the area of circle K in terms of pi. So we want area. We know we have to do pi times radius squared. They give us the diameter. So if the diameter equals 6 inches, you know the radius has to be half of that, or 3. So then all we got to do is plug that in. Pi times 3 squared, and we end up with 9 pi. And because it's said in terms of pi, we don't even need a calculator. We're done. The area is 9 pi, should put units on there, inches squared. So let's do another one. Find the radius of circle J if the circumference is 65x plus 14 pi meters. So circumference equals, we're trying to find the radius, so let's use 2 pi r that has the radius in it, and plug in what we know. The circumference is 65x plus 14 times pi, and this is 2 pi r. So if I want to get the radius by itself, I need to divide both sides by 2 pi. And then that eliminates these pi's. And then I can divide both of these things by 2. So 65 cut in half is going to give us 32.5x, and 14 cut in half gives us 7. And that's what our radius is. And we should include units here. So it's 65.5x plus 7 inches is our radius. So enough of circles, let's talk about regular polygons. So remember, the center of a regular polygon is equidistant from the vertices. So we go to this picture here. This is our center C, and each one of these are exactly the same distance away from the center. So a vertex goes from one of the points on the end to the middle. The apothem is the distance from the center to the midpoint of a side, and it has to be perpendicular to the side. So if we go back to this picture, this right here is an apothem. B is the midpoint of FE, and it is perpendicular to FE. So we could draw another one here. It would be perpendicular, and these two guys would be the same. The central angle of a regular polygon has its vertex at the center, and its sides pass through consecutive vertices. So all that means is when you have this angle right here, this is a central angle. And each one of these central angles is congruent because it's a regular polygon. If it wasn't a regular polygon, we wouldn't know about them, but because it is, we know all of them have to be exactly the same. So there's a quick little formula we can use. Each central angle is a measure of 360 degrees divided by the number of sides, and that's what n stands for, number of sides. So here's that picture again. Has a regular pentagon. The center is at C. Its apothem is BC, and its central angle they gave us was DCE. So to find the area of a regular n-gon with side length S and apothem A, divide it into n congruent isosceles triangles. So we're going to take this shape again, this pentagon, and because it has 5 sides, that means I can make 5 triangles out of it. And all of these triangles are isosceles because these right here have to be the same. So quickly, the perimeter is n times s. S, remember, is the side length. And because this is regular, all the sides are exactly the same. N, remember, is, if we go back, the number of sides that we used. And they give you that again, regular n-gon. So n is number of sides. You just take that and you multiply that by how many sides you have. So if I tell you one of the sides of this pentagon is 10, since there's 5, the perimeter would be 50. The area of each triangle is 1/2 base times height. So if we go back to one of these triangles, 1/2 our base is the side length here, and the height is the apothem. So we have 5 of these, or n of them, however many we have in our shape. So this is the area of a polygon. And then we simplify this. Because this is 3 different letters here, and we know the perimeter is ns, we can cross this off and say that the area is 1/2 a times the perimeter. So 1/2 times the apothem times the perimeter. And that's this formula here. So find the area of a regular heptagon with side length of 2 feet to the nearest foot. So the first thing I'm thinking is heptagon is 7 sides. So if each side has a length of 2 feet, I can quickly find the perimeter. It's got to be 2 times 7 or 14 feet all the way around. And we need that because, remember, the formula for area is 1/2 the apothem times the perimeter. Oops. 1/2 apothem times the perimeter. So now we know we're going to do 14 times something and cut it in half. Now the thing that makes this a lot more work is we need to know the apothem. So if you think you have your isosceles triangles inside of this, we have 7 of those triangles, and they tell us that this distance here is 2 feet because that's the side length. I need to figure out this distance here. That's what we need to find. So I know it has to be perpendicular, and I know it has to be a midpoint. So I'm going to take one of these triangles and use that to find this distance here. Now we need to know a couple things. The first thing is, because these are midpoints here, that ends up giving us the side length of this part here. We know it's 1 foot, because if the whole thing's 2, you got to cut it in half. Now we don't know any more information. We don't know the radius. That would be the radius here. And we got to find this, so we definitely don't know that. The other thing that we can quickly find is this entire angle measure here. If we go back to this stuff over here, the central angles for each polygon is 360 divided by the number of sides. So if we come back to our shape with 7 sides, we're going to do 360 divided by 7. If you throw that in your calculator, you end up with about 51.4 degrees. And that's this whole angle right here. But because we cut this triangle in half, we got to cut that in half. So we get that this is about 25.7 degrees. And now the side that we really are interested in is this one right here. This is x. So think back to your trig functions. What do you know and what do you need to know? We have opposite and we need adjacent. So I'm going to do tangent. And tangent of 25.7 is 1 foot over x, what I don't know. So then we have to manipulate some stuff and type it into our calculator. So you end up typing in 1 divided by the tangent of 25.7. And you end up with 2.08, or let's say 2.1 feet. And remember, that is our apothem. That's what we just found right there. So now we can plug it into the area formula. Area equals 1/2 the apothem times the perimeter. And we end up with about 14.5 inches squared. Nope, feet squared. We'll do another one of those in class, so if you got confused, write down what parts didn't make sense and we can talk about it. Because you should be able to develop and apply the formulas for circles and for regular polygons. Hope you have a good night.